This is the differential equations multiple choice. We're going to start with number 8. All right. Okay. So number 8 says, what should the initial velocity be if you want a stone to reach a height of 100 feet when you throw it straight up? And so in order to do this, you've got to sort of take a look back there at, it says in questions 1 through 10, the acceleration due to gravity is negative 32 feet per second squared, right? So we know that the acceleration is negative 32 feet per second squared. And if we have that, we want the stone to reach a height of 100 feet when we throw it straight up. We're looking for a velocity. So our velocity should just be the integral of this. Velocity is negative 32 t, right? Our velocity at any time should be negative 32 t plus some constant, which that constant is whatever our initial velocity happens to be, which tells us, when we'll call this our initial velocity. And then, so if we need to find the position, we'll integrate this. So our position, we'll call it S, should be negative 16 t squared plus our initial velocity times t. And then all we have to do with that, since we know that we are throwing this thing from the ground, I assume, yeah, throwing it straight up. So our initial position doesn't matter. We want to be 100 feet above where we were. We just need to set that equal to 100. And we need to figure out then what our value is. So in order to do that, can you guys hear me now? I don't know. Something was up with my laptop there.
Yeah.
Yeah, I thought you were just trying to figure out how to do the problem.
Oh, no. People said something. There's more questions in the chat. Okay, so in order to finish this off, we just need to figure out when it reaches that 100 feet. And so we want it to reach 100 feet, which means that we need our velocity in the end to be 0. And so if we set that equal to 0, we should be able to either solve this for t or solve this for v naught. Probably easier to solve this for v naught. If we solve this for v naught, that should give us v naught is equal to 32t. And if v naught is 32t, we should be able to plug that into here to get negative 16t squared plus 32t equals 100. And we should then be able to figure out.
Isn't it 32t squared?
Oh, sorry, 32t squared, yeah. Now I should probably multiply by the t. Then we should go solve that to get 16t squared equals 100. And t squared equals, what is that? 100 over 16, which is 5 over, not 5, 25 over 4. And t should be 5 halves. And so if t is 5 halves, we should be able to use that to figure out what our initial velocity needs to be. So that'll give us, if t is 5 halves, our initial velocity should be negative 16 times, what is that, 25/4 plus our initial velocity times 5 halves needs to equal 100, and we'll solve for v naught. That gives us -4. That gives us 200 over here. So 5 halves of v naught is 200. And that ought to give us 400 over 5, which is 80 feet per second. Good or no? Questions on that one?
So on this one, we just have to like use our knowledge of like the derivative of the acceleration as the velocity and all that stuff, and then.
Yep.
Okay. Why does it seem like a kinematics equation in like physics? Why does it seem like a problem like that so much?
Physics
Just when
is
I
all-
initially read it.
Physics
like-
is all based on calculus.
Okay.
All right, next one I got, or any other questions on that one? No? All right, next question here is 44. So 44 is a calculator question. It says at any point of intersection of a solution curve for the differential equation y prime equals x plus y, and the line x plus y equals 0. It says the function y at that point, and then it gives us a bunch of different choices there. So if those are going to intersect at a point, that would tell us that y prime, which is x plus y, needs to equal 0, which is also x plus y. So an intersection point there for those tells us that y prime is equal to 0, or our derivative equals 0, which tells us that we should have some sort of critical point there, which is either going to be a local maximum or a local minimum. So it looks like that's either going to be choice B or choice C. And so then we've got to go and figure out whether it's a local max or it's a local min. And we can use the second derivative test for that. So if we take the second derivative, y double prime, y double prime should just be 1 plus y prime, or 1 plus x plus y. And we know already that x plus y is equal to 0. So this is just equal to 1. And if the second derivative is positive at a critical value where y prime equals 0, it tells us that that should be a minimum. Does that make sense? So this is an example where that second derivative test for, you check your second derivative at a critical value where the derivative is 0 to determine if it's a min or a max. It's one where you wouldn't be able to any other way because you don't know the values of x and y at any specific point here. So you have to use that second derivative test. Does that make sense? Anybody have questions on that? All right, next one. is 45. We are given a slope field of using f prime of x equals e to the negative x squared. And then they've thrown onto that a function f of 0. And let's see, the limit as x approaches infinity of f prime of x. So they want us to figure out the limit as x approaches infinity of f prime of x is using a graphing calculator. That's kind of an annoying one. I don't know, since you had a graphing calculator at your disposal on that one, here's what I think I would do. That's kind of, I would be very surprised if you saw a question that looked like that. So, all right, so can you guys see Desmos or no?
No.
Sorry. So there's e to the negative x squared. But we've got some other, we got this value that f of 0 equals 0. And we know that our, I mean, that doesn't make any sense. That question doesn't make any sense. The limit as x approaches infinity of f prime of x. What did it say the answer was for that? Anybody know offhand what it says the answer is?
Choice A.
Choice A. With a graphing calculator, the limit as x approaches infinity of f prime of x to 3 decimal places. I mean, then the limit as x approaches infinity of f prime of x is 0. Based on the graph and based on just finding the limit of that as x approaches infinity. So I don't know what they're talking about there. Unless they meant the limit as x approaches infinity of f of x. That's the only thing that would sort of make some sense. I mean, the only way to do, if you wanted, maybe that's what they meant. So let me, if they meant f of x, I mean, this is 0, right? As x goes towards infinity, this is just 0. This is 1 over e to the x squared. And as x goes towards infinity, that's 0. So that, there's no question about that. If maybe they meant this, because they gave us this information that capital F of 0 was 0, right? So if this is what they actually meant, then we want to set this up as capital F is equal to the integral from 0 to some x value of e to the negative t squared dt. And we'd be looking for the limit as x goes towards infinity of this. So all you would do then is go in and use your calculator to evaluate this integral at just a fairly large value here for x. And I can just do that here in Desmos. So if we go from 0 to, I don't know, 100, yeah, you'd get 0.886. And so that's the limit as x approaches infinity of f of x, which is the value that they gave. So I think that's what they meant was f of x, but that definitely, unless I'm blind, that says f prime of x, right?
Yeah.
Yeah, so the answer to that should be 0. I think they must have meant f of x, not f prime of x, which would have been choice A. But yeah, that one I think they made a typo on. So. I wouldn't expect to see that on the AP test anyway. All right, next one I got is 50. We got the concentration of a medication injected into the bloodstream drops at a rate proportional to the existing concentration. The factor of proportionality is 30% per hour. We want to know in how many hours will the concentration be 1/10. So what we want to remember is that anytime we're talking about something being proportional to the amount of that same thing, that gets set up like a differential equation. We'll call it like a separable differential equation. So we'll call it I don't know. We'll call it D. What are we talking about? Medication, right? We'll call it dm dt is equal to, so the amount of medication that's in your system is decreasing, so it's going to be negative, and it decreases by 30%, so that'd be 0.3, 3/10, 30% of m. And so we could also, if we could write it like this, or we could just know that the formula should turn out to be m equals the initial amount of m e to the negative 0.3 t, right? This is the formula that we developed from a separable differential equation that looked like this, right? We divided by the m and took the antiderivatives, brought the dt over, and found your constant and all that stuff, and determined that the constant was equal to the natural log of the initial value, and we raised to the e and got that out in front. So this is the formula that you should be able to write based on the information that was given to you there. And then they want to know, what do they want to know? They want to know when the concentration will be 1/10. So we want the final amount to equal 1/10 of the initial amount. So we'll call this 0.1 m naught equals m naught e to the negative 0.3 t. The m naughts cancel. Take the natural log and divide by the negative 0.3. So natural log of 1, natural log of 0.1 over negative 0.3. And that, I don't know what that came out to be, but it comes out to be something. What would that come out to be?
7 2/3.
7 2/3, great. So anytime you see that the amount of something is proportional to how much of it you have, you should be able to set up this equation that we developed from these differential equations. Everybody good there with that one? Any questions on that one?
Nope.
All right, 54. According to Newton's law of cooling, the temperature of an object decreases at a rate proportional to the difference between its temperature and that of the surrounding air. Ooh, we're keeping a corpse here. That's exciting. So we have a corpse that is at a temperature of 32 degrees Celsius. Temperature is 10 degrees. And they want a differential equation that is satisfied by the temperature T of the corpse, little t hours later. So in order to do this, all we've got to do is use this this same basic idea that we were just talking about, right? We've got the change in the temperature with respect to time is proportional to, so we'll say, and we're going from 32 to 10, so it's going to be a negative K. And then it should be, it says the temperature and that of the surrounding air. So its original temperature, whatever its temperature is at that time, minus the surrounding air temperature, which is 10. That is 54. So the same basic idea that the amount or temperature, the amount of temperature that it has, the temperature is proportional to how much that temperature is, or what that temperature is at any given time, minus the temperature of the surrounding area, it says in this case. So it should be choice A, it looks like.
Why is the K negative?
Because we're going from 32 degrees Celsius to 10 degrees Celsius, it's decreasing, so it's like decay.
Okay.
All right, next one is number 4. Back to the beginning here. All right, so number 4 says, it's similar to the other one, I think, that we did at the beginning. A stone is thrown straight up from the top of a building. It's got an initial velocity of 40. And it hits the ground 4 seconds later. It's 4 seconds. We're looking for the height of the building in feet. So we're going to do the same basic thing that we started with on, I think it was number 8. We're going to talk about acceleration. So acceleration is negative 32 feet per second, which is going to then, again, tell us that our velocity should equal negative 32t plus whatever our initial velocity was, which was 40, because v of 0 has to equal 40, and the initial velocity has to equal 40. And then that will also tell us then that the height of the stone at any given time is negative, not 32, but negative 16 t squared plus 40t plus some other constant over here, which this constant, when t is 0, should be the height at which we threw the stone from. And so we want the position of this stone to be 0 when t is 4. So we'll just say 0 equals negative 16 times 4 squared plus 40 times 4 plus our constant. And what does that come out to be? 96, I think, for our constant. So our initial height when t is 0 is 96 feet. Does that make sense?
Yeah.
Let's see, we already did 8. That was the next one here on the list. 38 will be after that. So for 38, we are given, let's see here, ds dt equals sine squared pi s over 2. And we're given s equals 1, t equals 0. And we want to know what what t is when s is 3/2. So this is basically just like it's basically a separable differential equation here. So we could write this as ds over sine squared pi s over 2 equals dt And we could then write that as dt is equal to, we want it to cosecant squared of pi s over 2 ds. And then we're going to integrate both of these. And so if we integrate dt, we should just get t. And if we integrate cosecant squared, well, the integral of cosecant squared is negative cotangent. And so this is a u substitution there, so it becomes 2 over pi negative cotangent pi s over 2 plus a constant. And we know that when t is 0, s is 1. So that'll give us 0 equals negative 2 over pi cotangent of pi over 2. And the cotangent of pi over 2 should be what? Should know the cotangent of pi over 2. The cotangent of pi over 2 is 0. So this is 0 equals 0 plus our constant. So our constant is 0. So we've now just got t equals negative 2 over pi cotangent pi s over 2. And we want to know the value of t, is that right? Yeah, when s is 3 pi over 2. So t equals negative 2 over pi cotangent over tangent of, what did I say, 3 over 2? Yeah, so 3 pi over 4. And cotangent of 3 pi over 4, that should be negative 1, so this just equals 2 over pi. Which looks like that's choice D. And you had a calculator for that, so if you needed a calculator to evaluate the value, you can use it for that. But then you'd have to, it's going to give you a decimal, so then you'd have to go and see what each of those things was as a decimal. But any questions there on 38? Everybody good there?
Yep.
Next up is 42. Let's see here. So 42 says we got g prime of x squared equals g of x for all real x, and g of 0 is 0, and g of 4 is 4. We want to know what is g of 1. So in order to figure this one out, let's see here. What should we do here? I guess we could just say that g prime of x is equal to the positive or negative square root of g of x. That seems like a good place to start. And that would tell us that when we plug in when we plug in 4 to g, we need to get out 4, which means we should be looking at the positive values here. Let me think about this for 1 second. I haven't looked at this one. Okay, yeah, so if g prime is positive or negative square root of g of x, and clearly it's going to be the positive because we're going to, g prime of x squared is going to equal g of x squared. This is all going to be positive terms. If we know that g prime is the square root of g of x, we know that we can integrate this to figure out what g of x actually is. And so if we integrate the square root of a function, then we should end up getting, nah, that's not going to work out. Let me think about this for a second more. This one's a pain. All right, here's what I'm going to do with this. I'm going to rewrite this g prime. I think this will work out. I'm going to rewrite this. I'm going to say, let's let y equal g of x. Just call the function g of x y, just to put it into some more familiar looking variables. So g prime would be y prime or dy dx. And then g of x, that'll give us the positive or negative square root of y. And so now we've turned this into what looks like a separable differential equation. And so we could call this, like we already said, we're just going to have the positive terms of this. So dy over root y equals just dx. And when we integrate both sides, that should tell us that 2 root y is equal to x plus some constant. And if we plug in 0 for x and 0 for y, we can see that that constant should be 0. So we're really just looking at this. 2 times the square root of g of x is equal to x. And so if we want to figure out what g of 1 is, y equal g of x, so if we want to figure out what the value at g of 1 is, we just need to solve this for g of 1, which should be g of 1 ought to be 1 over 2. If I bring this 2 over, and then you square it, which should be 1/4. Is that one of the answer choices? Oh, good. Choice A, is that right?
Yeah.
That's a little complicated too. I wouldn't expect to see something exactly like that, where they're making you switch the variables around to turn into like this separable differential equation. That was kind of a pain also. No other questions on that one? All right. Let's see here. Number 5. All right, number 5 was sort of an addition to number 4. It says the maximum height that is reached by the stone in question 4. So when we were doing, let's see, we did question 4 a bit ago, right? Question 4, we ended up with the height of this thing was equal to negative 16t squared plus 40t plus 96. And negative 16t squared plus 40t plus 96 is the height. We want to know what is the maximum height. And so in order to find a maximum height, we take a derivative, which we already had, which was velocity is negative 32t plus 40. Set that equal to 0. And it tells us that we should hit a maximum. And we know this should be a maximum because this is just a parabolic equation with an a value that's negative. So it's going to be concave down. It's going to have a max. We should get that that occurs when t equals 40 over 32 or 5/4. And so then we would just plug 5/4 back in. No, sorry, no, never mind. We wouldn't need to. It just says after 5/4 seconds. It doesn't ask for the actual height. It just says when does it reach the maximum height. So looks like choice C for number 5. Good or no?
Good.
Any questions there on 5? All right, 39. All right, 39, radium decomposes at a rate proportional to the amount present. So this is the same kind of thing that we've been talking about, where it's just the amount of it is proportional to the amount of it present. Let's see, so what do they want us to do? They just want us to show that we know that that's R equals R naught E to the, and then C is a negative constant. They've already said that, so just to the C times T. And you can always go in and write, dr dt equals C, but then you just gotta do the integration. So it's helpful to just know that that's the, this is the y equals y naught e to the kt formula that we derived way back when. So that's all there is to 39. It's just knowing that formula. Everybody good there or no?
Yep.
All right. Next up is 19. So, number 19, we got a curve passes through the point 1, 1, and we have its slope is 3y over x. We want to know what is the equation here. So, slope is 3y over x, that's dy dx. And so we should be able to rewrite this as dy over 3y equals dx over x, and integrate both sides of this. So that'll give us 1/3 natural log absolute value y equals natural log absolute value of x plus a constant. If you plug in 1 and 1 here, you get 0 equals 0 plus c, so your constant is 0. And what do they want us to solve this for? They just have it left like that. So we got 1/3, and maybe might be nicer to write it just as natural log of y equals 3 natural log of x. Because there's discontinuity at x equals 0, we're only really concerned about the positive half of this, because our initial condition is on the positive half of it, so I can ignore the absolute value, which is why they've ignored them in their answer choices. And then we should then, let's see, we're going to that doesn't work out to any of their nice little answer choices, does it? Oh yeah, it does. I know how to do arithmetic. Raise this to the e, this becomes y equals, and then this is e to the ln of x cubed. Remember that you can put an exponent in there, or a coefficient in as an exponent. So this just becomes y equals x cubed, which looks like that's choice C. Any questions there on 19? Right, next one was 20. Now they want to know what is the domain of that solution from number 19. And so we already sort of said that the derivative value couldn't have existed or not a derivative, but that our function couldn't have existed when x equals 0. Our derivative also couldn't exist when x equals 0, just because we ended up with natural log of the absolute value of x. And so then we would just go through and say, well, it's got to be positive values because we pick the continuous portion of our function that includes our initial condition with a discontinuity x equals 0. That means we've either got negative infinity to 0 or 0 to infinity. And since 1 is on 0 to infinity, we'll pick x greater than 0 or 0 to infinity.
Is this the whole like interval of validity thing?
Yep, that is exactly what it is. Everybody good there with 20? All right. I guess we're going back to the beginning here again, number 6. So let's see, what does number 6 say? We've got a car that accelerates from 0 to 60 miles per hour in 10 seconds. We want to know what distance it travels in those 10 seconds. And it says assume that the acceleration is constant, noting that 60 miles an hour is 88 feet per second. So let's see, we want to figure out how far it travels. So we should, it's going to accelerate by 10 miles or by 6 miles per hour every second. That should be our acceleration. If it's going from 0 to 60 miles per hour in 10 seconds, that should tell us that our acceleration ought to be 6 miles per hour per second. But then we've got to convert that into a number of feet per second squared to deal with this in like regular terms. So let's see, 60 miles an hour. So 6 miles an hour ought to be 8.8 feet per second. So this ought to just be 8.8 feet per second squared based on the conversion that they've got there. And then from there, we'll need to figure out what the velocity constant is. So we've got v of t should be 8.8 t plus some constant. And since we know that it started at v of 0, velocity of 0, this constant is going to be 0, right? If v of 0 is 0, then this should just be v of t is 8.8 t. And then we need to find the position. So the position function will be the integral of that, which will be 4.4 t squared plus some other constant. And if the position at 0 was 0, then we know that our position is 4.4 t squared. And if our position is 4.4 t squared and we want to know where it is after 10 seconds, we just plug in 10 to that, which should give us 4.4 times 100, or it has traveled 440 feet. Good or no?
Good.
Perfect. Any questions there on 6? All right, next one is 7.
You don't have to do that one. I'll retract my question there just because I got it.
Okay, well, somebody else later asked for it, so since I'm already on that page, I'll just do 7 right now also. Okay, so 7, we've got a stone is thrown at a target so that its velocity is 100 minus 20 t feet per second. The stone hits the target in 1 second, and we want to know that what the distance from where we're Apparently it's from a sling. They didn't mention that. We want to know what the distance from the sling to the target should be. So we've got our velocity function. So in order to figure out a position or a distance, we'll just integrate that 100t minus, and this will become 20t squared over 2, so minus 10t squared plus some constant. And since we know that at t equals 0, the position was 0, that tells us that our constant is 0. So our position is just 100t minus 10t squared. And if we're looking for that at t equals 1, that ought to be 100 minus 10, or 90 feet away. Everybody good there with number 7?
Yeah.
All right, next one is 38. No, we already did 38, never mind. Let's see here, 38. All right, next one is 55. Okay, so 55 is back to that Newton's law of cooling problem, it looks like, right? So it says if that corpse cools to 27 degrees in 1 hour, so let's go back to that problem somewhere. There it is. All right, we'll just do 55 right here. So we are now saying that the corpse is going to cool to 27 degrees in 1 hour. We want to have an equation to represent its temperature in degrees Celsius. So we know that the temperature of it should be following this equation. So we should be able to solve this differential equation. So this should be dt over t minus 10 equals negative k dt. If we try to solve this differential equation, we should get natural log absolute value of t minus 10 should be equal to negative kt plus our constant. And our constant we should be able to find because we know that it's going to cool to 27 degrees in 1 hour. So our initial temperature was what was it again? It was 32, right? So our initial temperature was 32. So when we plug that in, along with 0 for t, we get our constant of the natural log of 22. So we're now looking at natural log absolute value t minus 10 equals negative kt plus ln 22. Let's write that also. Negative kt plus ln 22. And then we should be able to raise that all to the power of e, which is going to give us t minus 10 equals 22, and then e to the negative kt. And we know that, I need some more room here for this now. We know that after, what was it? How many hours was it? It was 1 hour, it's cooled to 27. So we're going to plug in 1 for t and 27 for that final temperature there. So we're going to say 27 minus 10 equals 22 e to the negative k. And then we will solve for k. So that's going to give us 1720 seconds equals e to the negative k. Take the natural log of both sides. It's going to give us natural log 1720 seconds equals negative k, or our k value should be, I don't know, what does that come out to be? Anybody have the natural log of 17 over 22? Then the opposite of that?
I got 0.257829.
We'll round to 2.258 since that's what we normally round to. And so now we've got our k value, so we'll just go back in and write our equation. T minus 10 is what we had, equals 22e to the negative 0.258. That's negative k t. And that should be the equation, which looks like that's choice. Well, they added the 10 over, but 10 plus 22e to the negative 0.258t, so choice C. So that's just a matter of, that's sort of like the baby bird and the trash problems that we did, right? You're just solving given an initial condition. In this case, you had to find the constant also, whereas it was given to us, like the k value was given to us in those other problems, but this time we had to find it. Does that make sense to everyone for 55?
Yeah.
Okay, next one is back to the beginning again, number 2. So for number 2, we are given acceleration as 20t cubed minus 6t, and we're given that the initial position at -1 is 2, and that s of 1 is 4, and we're asked to find what v of t is equal to. So this one's a little bit complicated. It's not too horrible, but first thing we want to do is integrate our acceleration function to get v equals 5t to the 4th minus 3t squared plus some constant. Right? And we're going to call that constant 1 because we're going to end up with another constant in here. And we're only given initial position values, so we're going to have to integrate again to get s is t to the 5th minus t cubed plus, well, that first constant times t plus some other constant. And that should allow us, so we've got 2 different initial positions. It should allow us to set up a system of equations where we can solve for both of those constants. And if we have both those constants, we can go back in and find what C1 is. We'll have C1, we can find the velocity equation. So if we plug in 1 to this, we should get 4. So I'm plugging in 1 for t, 1 minus 1 plus C1 plus C2. So we know that constant 1 plus constant 2 equals 4. And if I plug in -1, this should come out to be 2. And we get 2 equals -1 minus -1, so plus 1, minus constant 1 plus constant 2. So that tells us that negative constant 1 plus constant 2 is 2, constant 1 plus constant 2 is 4. We can take one and add it to the other, or take one and subtract it from the other. Either way will work. Let's say we subtract one from the other. So let's take this one and subtract this one. So 4 equals C1 plus C2. And if we subtract, we're going to get 2 minus 4 is -2. Negative C1 minus C1 is -2C1, and then C2 minus C2 goes away. And we'll get constant 1 should be equal to 1. So if constant 1 is 1, then this should be 5t to the 4th minus 3t squared plus 1. That makes sense for number 2?
Yeah, thank you.
Mm-hmm. And then we had number 3 also. So number 3 was asking, given our A of t and s of -1, s of 1 is in question 2, we want to find out what s of 0 equals. So if constant 1 was 1, that's going to tell us that constant 2 is 3. So that should tell us that S is equal to t to the 5th minus t cubed. What do we have? We have plus t and plus 3. And it's asking us for S of 0. So S of 0 ought to just be 3. Any questions there on number 3?
This is just like a general question. How long on like average do we get like per question for the multiple choice? Like how long can we spend on each question?
So for the non-calculator, it's 30 questions and you have an hour. So you got, on average 2 minutes per question. The multiple, that's the non-calculator. Did I say non-calculator? I hope I said non-calculator. Yeah, the non-calculator, 60 minutes, 30 questions, so 2 minutes a question. Then the calculator is 45 minutes for 15 questions. You got 3 minutes per question on the calculator ones.
Okay, thank you.
Mm-hmm. All right, let's see, that was 3. 7, I already did. Let's see here. Next one up should be number 9. So number 9 says, looking at the velocity of a car traveling in a straight line, the difference in its odometer readings between t equals A and t equals B. Okay, well, they're assuming you know what an odometer is. Hopefully you know what an odometer is. An odometer just measures the total distance that you've traveled, right? And that's total distance, or since we're traveling in a straight line, it says, if we're just going in a straight line in one direction, then that's going to be the same as our displacement. But let's see, I guess it doesn't say, it doesn't say that it's traveling in a straight line in one direction. So we're just going to say the odometer tells us our total distance traveled. And so since the total distance traveled can only be found by integrating the speed, we want to integrate the speed. And the integral of speed is the integral of the absolute value of the velocity. So we want to integrate absolute value of velocity to find a total distance traveled. Good there on 9?
Yeah, I thought the odometer was something else.
That'd be a problem if you don't know what an odometer is. My guess is if this was the actual AP test and they asked something like that, they would define what that is for you. But since this is just from a review book, they didn't. All right, next one, we got a couple more here. Next one is 24. They've shown us a solution curve for a slope field. The solution is for the differential equation and initial condition. Okay, so it looks, if you're looking at that slope field, it looks like a bunch of tangents that we've drawn, right? So like it's drawn this. Right? These are our solution curves, appear to be tangent functions. And solution curves are tangent x. And so we need to figure out which of these things represents a derivative that is tangent of x. And so we know that if the solution is y equals tangent x, then that tells us that, let's see here, we need to find our y prime see. The one that looks like it makes the most sense is y prime equals 1 over 1 plus x squared. But there's an issue with that. It says that y of pi over 4 equals 1. That's not true. If I plug in pi over 4 into y of pi over 4 equals 1. Yeah, I mean, the only issue with that is we can't actually see that we're hitting pi over 4 and 1. But those solution curves, we can see that we're hitting the point 0, 0. And so, yeah, that one's sort of a little too tricky for them to put on the AP test, because I think my guess is the answer they show is probably choice E for that one. Because E is also right. Yeah, so E comes from this: x equals the inverse tangent of y. Right, if y equals tangent of x, x is the inverse tangent of y, which would tell us that dx is 1 over. Oh, this is not even the derivative of that. That's, never mind. That's not tricky at all. Y equals inverse tangent of x. Y prime would be secant squared x. I don't know what I'm doing. I don't know what I was thinking. Sorry, y prime would be secant squared x, which that's definitely not any of these. So the way to get this is to get dx is 1 over 1 plus y squared by writing this in terms of x. And so then we would see that our value should be, let's see here. So dx dy would be 1 over 1 plus y squared, which would tell us that dy dx, or y prime, would be 1 plus y squared. And now when you plug in 0, 0, it goes through your point that you're looking for. But y prime is secant squared x. That's not an answer choice that's given to us, so it certainly can't be that one. So it'd have to be choice E. I wouldn't expect them to throw something at that like this at you, where you've got to take the inverse of it and do it that way. But that's how you do that one. I don't know why I was thinking for a second the derivative of tangent was 1 over 1 plus x squared. That's atrocious. Good or no?
Yeah, good.
All right, last one we've got here is number 16. So number 16 says we've got the general solution of the differential equation x dy equals y dx. And they want to know if this is circles, hyperbolas, parallel lines, etc. A bunch of different options. So in order to figure that out, let's actually integrate it. So we need to do then dx over x equals dy over y. And that gives us natural log absolute value y equals natural log absolute value of x plus our constant. And if we were to go through there and solve this for y, we're going to end up with e to the natural log y, e to the natural log x plus c, which just gives us y equals, this would just be e to the c, which is some constant out in front, times x, and this is just a number times x. So it looks like those should just be some lines, and those lines, if there's no plus a 1 or plus a 2 or anything, this tells us that our y-intercept is 0. And so they should just be lines that pass through the origin, which looks like it's choice E. Does that make sense to everybody or no?
Yeah.
All right. Any other questions? That's the last one people had asked for. And we're almost out of time here. So got like a minute left.